Hello, Precalculus. The e-learning continues, and here we go with Chapter 10. It is a 3-lesson chapter, and we just about doubled the number of days that we usually spend on it to give you guys as much time as possible to process and practice this information during our quarantine. So let's just jump right in. So this is 10-1, day 1. We're going to talk about sequences, and the goal of the day is to find the terms of sequences and to write 2 different types of rules for those sequences. We'll break this up into multiple videos, and I'm sure you're going to enjoy it. Let's just get started. A sequence is a function with a domain that is the set of positive integers, and I believe that's what Math Excel is going to ask you for. Let's see if I can spell. And some other textbooks also refer to it as your natural numbers, which are the first numbers that you learned when you were learning how to count. Yeah, it looks crappy, but we'll keep going. And so we're going to use the word terms every single day. Those terms of the sequence correspond to the range or the output elements of the function. And so if we just zoom in for a second here, so this would be the first term, second term, third term, and then all the way up to the nth term, which will have some different formulas for that every day that we're practicing. All right, what else is going to happen? So some of the sequences that we look at, most of them will be finite. So maybe there's 10 terms, maybe there's 1,000 terms, but we will also see some sequences that are infinite, just going on forever and ever, kind of like my ramblings in class. So here we go. What else? 2 different formulas. So the one that is less friendly is called recursive. They're usually easy to write, but a recursive rule, it depends on the previous term. So if I ask you for the 15th term, it means you have to know the 14th. But the only way you're going to know the 14th is if you know the 13th, and the only way to get that is to know the 12th, and so it's tedious that you have to know every single term that came before it. It's usually easy to write the rule, but not as convenient to use the rule. So the one that you're going to love more than anything is an explicit rule. And on the explicit formulas, you can find any single term. You want the 54th term, put 54 in for n or whatever variable you have, and you'll get the answer. All right, last bullet point here. If your sequence, your list of terms, I already used that color, is approaching a specific value. Sometimes it's 0, sometimes it's a positive number, sometimes negative. There's no rules on that. It is called convergent. It's converging to a single number. Convergent. But sometimes the numbers alternate back and forth between positive and negative, and they get farther and farther away from 0. Sometimes they might seem random and they don't get close to any number. Sometimes they'll shoot straight up to infinity or negative infinity, and that is divergent. So if we were in class, I would make some silly joke about the series of books, but I'm not going to do that today. And so I have 4 pictures here, and then we'll take our first break. I got these graphs from the internet, but they summarized exactly what I wanted you guys to see. So if we look at this first situation, those points, there seems to be no pattern. They're positive, they're negative, they're not getting to any specific value, and so we would call that divergent. When we look at number 2, the numbers were going back and forth, but they got closer and closer and closer to a single solitary number right here, and so they are converging to that number. All right, quick side note here. I added this. These notes are brand new. I'm sure you're going to love them. I brought back our limit notation because one thing that you can do is later on I'll encourage you to look at the table, but you can also just put a really, really big number in for n and see if you get a number out. Great. If you get some gigantic number close to infinity or negative infinity, then you know that's going to diverge and not converge. And then number 3, that looks like your exponential decay from chapter 3, and so that is going to converge. And number 4 looks like your exponential growth from chapter 3, and you can see it's going to go up and up forever, closer to infinity, and so that would be divergent. And let's pause for our first break, and then we'll jump into some actual problems. See you later.